our equation will become m upon h will be equal to mu r minus 1, and from that you will get the value of m. So let us move towards slide. Now it will be easy to understand that chi is equal to mu r minus 1. Now instead of that susceptibility, we will substitute the equation of m upon h. By substituting the values of h, mu r, we will get the values of m, and m is nothing but the values of magnetization for your paramagnetic material on which you are applying the field. The answer, when you will calculate the answer, you will get the 2000 ampere per meter. The answer is 2000 ampere per meter. Let us move towards next question. Discuss briefly about types of sound absorbing materials. The types of sound absorbing materials are classified into following 4 categories. The first one is porous absorbent. The second one is cavity resonator. The third one is panel absorbers. It is also represented as resonant absorbents. And the third one is composite absorbents. So these are the 4 types which you are going to study in our question. These are the 4 types which are classified for sound absorbing materials. Let us move towards the first point, that is porous absorbent. What is the work of an absorber? The absorbers are mostly used in sound recording rooms as well as in the rooms where there is the need to absorb the sound due to much loudness or due to extra noise created inside any room. We should use the sound absorbing materials, from which the first one which is classified is porous absorbents. Whenever sound wave strikes the porous material, what will happen? A part of wave which will get reflected from the other part enters the porous material. That means a part of wave will get reflected and a part of wave will get entered into the material. Through entering into that material, the material will resist or damp the effect of the wave. That means it will absorb the energy of the wave and convert that energy into heat energy. And when a partly reflected wave, it will reflect from that absorber by losing somewhat energy. So the energy or the sound wave which is reflected from an absorber will be not much more effective as it was when it was traveling. When it will strike the sound, it will strike the sound absorbing material, much more energy will be lost in the form of heat energy. Let us move to the next slide. The part of reflected wave energy is reduced, while the part of energy that enters into material, it is converted into heat. As I said, the part of energy is reduced while reflecting, while the part of energy which is passing through the sound absorbing material is converted into heat. Somewhat examples which are used as sound absorbing materials, or you can say porous materials. The porous materials means those which is thinner from inside. Fiber boards, rock wood, wood wool, glass silk, etc. are the types of materials which are used as porous absorbers. Let me talk about cavity resonator. Actually, this cavity resonators are a type of chambers which are used to absorb some particular type of frequency of sound waves. That means it will absorb some particular frequencies Suppose in an air conditioned room or air conditioner chamber, the sound wave or extra sound wave or a machinery chamber which is creating extra sound will get absorbed by the cavity resonator. Let us move again. When sound waves strikes the cavity resonator, or when it enters the cavity resonator, cavity means a space in which sound wave will enter. Due to multiple reflection inside, the sound wave gets absorbed. That means when sound wave is entering the cavity resonator, the sound wave will perform multiple reflection inside the cavity resonator. The cavity resonator is a chamber with a small opening for sound waves to enter. That means when sound wave will enter the cavity resonator, it will perform multi reflection, or it will get reflected for multi times. Through this many reflections or more than one reflection, the sound wave will lose its energy by performing many reflections. So when it will get out from that chamber, it will not have any particular energy through which any extra noise is heard. That means cavity chamber will work as a sound absorber, which will absorb the sound by multi reflection and losing the energy of sound waves. Let us move towards the next slide. The cavity resonator may be designed to absorb sound wave of a particular frequency. As I said, cavity resonators are particularly designed to absorb some particular frequencies which are generated by machineries or machines such as air conditioners, plant, and some particular type of machines. That frequencies are absorbed by cavity resonators. Now let us move towards next slide. These are the panel absorbers. What do you mean by a panel? Panel absorbers are a type of absorbers which can be hanged on a particular wall. In this system, the absorbent material is fixed on a framing with an air space between the framing and the wall. That means when panel absorbers are fixed on a particular type of walls, there will be a air space between framing and the wall, which will absorb the sound absorbing material, which will absorb the sound waves. The example are rigid plastic board panels, wood and hardboard panels, and suspended plaster ceilings. What do you mean by suspended plaster ceilings? You have seen many a times that on the ceiling surface many ceiling or plaster boards are suspended. That plaster boards are nearly used to absorb the sound energy or extra sound. Let us move towards the next point. When sound waves strike this panel, they do or due to the flexural vibration, this panel experiences flexural vibrations which will decrease the energy of that sound wave. That means certain amount of sound energy is absorbed by the panel through flexural vibrations, which is converted into heat energy. And when this sound energy is converted into heat energy, it will not be heard extra sound. Let us move towards the next slide, that is composite absorbents. Composite means there is a composition between two or more things. That means composite absorbers is a single unit which does the same function as the above three absorbers. As mentioned above, we have mentioned the three types of absorbents. One is porous absorbent, the cavity absorbents or cavity resonator, or panel absorbent. All three work functions are conducted by, or it can conduct, or composite absorbent can conduct the all three absorbing system. The composite absorbents consist of a perforated panel fixed over an airspace containing porous absorbents. When sound wave strikes the panel, they pass through it and it is damped by the resonance of the air in the cavity. That means the airspace and the cavity will damp the traveling of these sound waves, and due to which the sound wave will be absorbed in the composite absorbents. Let me show you some images which are the types of sound absorbing materials or sound absorbing panels which you can observe on many types of walls or many type of sound recording rooms, or which you have seen when you have visited many type of halls or acoustical halls. Let us see these images. These are the types of images. You can see the porous images where sound wave will strike and the path of that sound wave will get damped. Let us see one more images. These are the images which are having some cavities, as well as this material are porous materials which will absorb the sound energy. Now this third diagram represents the type of material which is fixed on the wall. This type of material which is fixed on a particular type of wall will also absorb the sound and will control the acoustic inside the hall or a particular type of room. So this was the question. We will conclude up to this. Thank you.